Okay, for this problem, we want to find the derivative of the function using the definition of the derivative. So this is the function that we want to take a derivative of. Okay, so this we haven't gone over class, but here is the definition of what the derivative is. F prime of x, so this thing, I'm just going to write it over here, is how we say f prime of x. So that's how we're going to say that. That's what we're going to call the derivative. Okay, that's a derivative. Okay, now this is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. So hopefully this looks very familiar because this is the same thing as the instantaneous rate of change. So the only thing that we're not doing here is that we're not evaluating at an x value. We're just finding the formula and then that's it. And evaluating the limit and then we're done. Okay? So let's go ahead and just use it. So this is the formula. We want to figure out what f prime is. Okay, so f prime is going to be equal to all of that. So first let me write the limit as h goes to 0. Okay, now we already know what f is. F of x is just this thing. That's just what f is. What about f of x plus h? Okay, what is this? Well, f of x plus h is just plugging in an x plus h in to the x. So I'm going to put an x plus h here because there was an x plus h, and then an x plus h here. Okay, so now let's go ahead and plug this in. So I'm going to have, so in the green part, okay, I'm going to have x plus h whole quantity squared minus 2x plus h plus 1. Okay, and in the blue part, I'm going to have this thing, which was just x squared minus 2x plus 1. So notice that the only difference that the blue and the green have is that this one has an x plus h in the inside. This one doesn't have. It just has a regular x. And now on the bottom, I just have an h. Okay? So let's continue doing this problem. So we're going to have limit. So don't forget about this. Limit as h goes to 0 of, now the top part, I'm going to FOIL it out. So this part, I'm going to FOIL it, and that's going to be x squared plus 2xh plus h squared. So when I FOIL all that, I get that. This part, I'm going to put it in purple. I'm going to distribute the negative 2 and have minus 2x minus 2h. Okay, and then I'm just left with the plus 1 here. Plus 1. Okay, so that's what's left over there. Okay, now for the blue part, all I have is to distribute this negative. Okay, so this is going to be negative x squared plus 2x minus 1. And this is all going to be over h. Okay, all right, let's continue. All right, limit as h goes to 0. Okay, so now let's go ahead and drop the brackets. So we have x squared plus 2xh plus h squared minus 2x minus 2h plus 1. Then I have minus x squared plus 2x minus 1. So all I just did was got rid of the brackets. Notice that the x squareds are going to go away. What else goes away? The 2x's go away. My 1's are going to go away. And then hopefully the only thing that I have left on top is just h's. Okay, or things that have an h. Okay, so on the top I have a 2xh. Then I have a plus h squared, a minus 2h, and then divided by h. Now all we got to do is just evaluate this limit. So when we evaluate this limit, well, first if I plug in 0, I'm just going to get 0 over 0 indeterminate form. So let's factor the top part because we have a quadratic. Limit as h goes to 0, I'm going to factor out an h. This one has one less h. This one only has one h. This one has no h. And then I have an h on the bottom. So now the h's go away, and I'm left with the limit as h goes to 0 of 2x plus h. And now we plug in the 0, 2x plus 0, which gives me, oh, no, minus 2. I've got my minus 2. Plus h minus 2. Okay, so now I'm going to plug in my h plus 0 minus 2. And now what I'm going to get is 2x minus 2. Okay, so my derivative, I'm going to write it over here, my derivative f prime of x is equal to 2x minus 2. That is my answer. Okay, now for those that know the power rule, you can go ahead and use the power rule, but there will be a problem where you have to go through all this mathematics. Okay, so I will show you what the power rule is. It's a little bit more easy to do, and it'll save you all of this time. So for right now, just do it using the definition of the derivative, and in class next week, we will go ahead and do the power rule.